Okay, I'm going to try and do a quick video on how to direct wire a smoke detector into an extension cord so that you have a disconnect for your 3D printer in case of fire or smoke of any kind. So you're going to need a few parts. First, you're going to need a smoke detector. This one's 120 volts. I'm in Canada. I'm sure can get 240 volt or 220 volt depending on which country you're in. You'll need a relay module for your direct wire smoke detector. You'll need a junction box of some kind. You'll need a female cord end and a male cord end, as well as some 14 gauge or 2 millimeter cord. And you'll need some tools, some screwdrivers, some wire strippers. You'll need some electrical tape and some barrettes. And in the end, we'll check some voltages with a voltmeter or multimeter and a circuit tester. Okay, so for the first part, we'll start by making the cord ends. So for this, I'm using the male cord end and the female cord end and my cord. I have some wire strippers, a screwdriver for the cord ends, and a knife to strip the wire back. So it's important that when you strip the wire back, you don't strip too much wire. You don't want to have any of the bare wires sticking out past the connector. So we'll just start by stripping it. Another thing to worry about is ringing the wire. We don't want to cut into the wire by cutting this way. So we'll start by making a cut lengthwise. And once we've got it past the rubber, we'll peel it back. And we can cut a little extra right now, and we'll shorten our cut once we have a measurement for putting it into the cord end. Once you've got the cord stripped back, you can take and open your cord end, and they comes in all kinds of different shapes and sizes and ways of connecting it, so you'll just have to find one at your local hardware store or electrical supply. When we strip the wire, we got to be careful to use the correct rating on your strippers so that you don't cut any extra wire. Any stress points on the wires can cause extra current flow, and that'll heat up, and that's where you'll have your arcing and sparking, and it can cause its own fire. As you can see, I've only stripped back just enough to go into the connector and not leave any extra wire sticking out past the connections. I always start with the ground wire just to have it, and then go next with the neutral, and then lastly we do the line. You don't want to over tighten. Again, if you have a poor connection because of over tightening, it can cause arcing and sparking, and it's not safe. As you can see, when I close this connector, there's no rubber or no wires going past. I only have the rubber insulation on the outside. And also, if you look at the connections, you want to make sure that there's no copper showing coming outside of the connector. So I'll go ahead and close this up. And now I'll start on the female side. So again, you take care not to cut the inner wires and make sure you don't ring the wire. You do your cut lengthwise and then you cut around after. Usually your cord ends will have these paper pieces. They can just be cut off. So again, you want to check your length, make sure that you're going to be covered so that the clamps go on the insulation and not on your wires. Strip the wire. Again, take care that you're using the correct notch in your strippers. So again, start with the ground. A ground screw can also be called the bond screw, depending on where you live. Doing neutral wire next. If you're in North America anyways, the ground bond screw will always be green, the neutral will always be white, and generally the hot or line will be a brass color. You want to make sure that these go in. Well, they're just the clamps, So if you have different size wire, you can turn those so that they clamp properly. Okay, so again, check to make sure you haven't pinched any wire, and you don't need to over tighten that as well. Just make sure the cord doesn't slip out. Okay, so for this next part, we're going to take our cord that we just made, I'm going to cut it in half, and we're going to put it into this junction box and get the bond screws or the ground screws connected to the ground wire in this cord. You always want to make sure that any metal parts are bonded to ground or grounded, and we always start with that. So I want to be able to put this smoke detector as close to my printer as I can. So I'm just going to cut this cord in half, and now we're going to do the same thing as we did with the cord ends. We're going to strip back about 10 inches, so I guess 25 centimeters, and we'll get started. Again, you can cut off the paper bits. They're just put in there to keep the cord nice and round so that you don't get a funny shape when they put it together. Generally speaking, you want to cut away from yourself. I want to make this approximately the same length. Okay, so now you want to check the length of your wire and make sure that you didn't nick it anywhere when you were cutting it. It's important that you're careful. I would recommend, if you did nick it, to just cut and start again, shorten your length. So for my application, I want to come in on the same side of the box. Depending on where your electrical outlet is and your printer, you can come in on one side or the other, or depending on how you're mounting your box. For me, I'm going to come in on the same side for both. Okay, once you've got these inside, you want to make sure that the insulation from the outside is going past your clamp, and you can tighten down on your clamp. It's really important that when you tighten down that you don't tighten too much. You just want to make sure that these are snug and they won't pull out if they're accidentally pulled on. If you tighten them too much, you can actually squish the insulation on the wire themselves and they can short out. And again, they'll trip your breaker or blow your fuse, or at worst they can start a fire as well. So our smoke detector doesn't require a ground or a bond. So I'm going to strip these bond wires right at the end. An option also is to strip them back here and to curl them around the bond screws in the box. Those are those ones right there. Again, select your correct gauge. I'm picking 14 gauge. Okay, so you want to make sure that that ground screw is nice and tight. You want to make sure that your wires aren't frayed at the end. So next I'm going to strip our two sets of incoming and outgoing wires. And here we don't want to strip too much. We want to strip enough that we'll have a moret on our smoke detector, but not so much that the wires strip back past our moret, and I'll show that when I do the connections. Okay, now it's important that we know what our line in is and our line out. So obviously the male plug will be plugging into the outlet, and that will be our line in. And my line out will be these wires here. So these ones will be controlled by the smoke detector and the relay, and these ones here will be live all the time when the extension cord is plugged into the wall. So this smoke detector is a direct wire, 120 volt, like I said, for North America. In Europe or Australia, you'll have 220 volts, or 240 it might say. This is a 3-wire system. So what that means is there's a hot and neutral, those are your power wires. And the red wire here is a signal wire. So if you have 4 or 5 of these in your house, and one of the smoke detectors senses smoke or carbon monoxide, depending on the type you have, it'll send a signal through this red wire, and it'll trigger the other smoke detectors. The output on this red wire, it would be great if it was a 5 volt or a 9 volt signal. However, they have their own encode that they send, which makes it really tough to use that signal wire in a contactor. But you might be able to purchase a smoke detector that has either a built-in relay, which I have an adapter for, or sends a 9 volt signal or 5 volt signal, in which case you could use a either solid state relay and use the contactor side to switch your cord, or you could put it through a regular relay if it was a 9 volt AC signal, and just use a contactor and do the same thing. So I purchased a Kidde relay. So what this does is it takes the 8-bit signal that comes out of the smoke detector and converts it through this relay, and it actually gives you a few options. You have a normally open and a normally closed set of contacts. I'll see if I can zoom in on that. So if you have a look, there's a few options there. I'll talk about the amp rating there as well. So you want the relay or the contactor that you're using to be able to handle the load of your printer. So my printer I looked at is 270 watts, and that for 110 volts works out to 2.45 amps. If your contactor is too small current rating or watt rating, you risk the chance of burning it out, or it failing in some way, and either your printer will never turn on, or in case that there's a detection of smoke and your smoke detector goes off, it won't open the contacts like it's supposed to. So you definitely want to pay attention to the current rating of your relay. Okay, so I've taken the smoke detector out of the package. In the package for the smoke detector, there's a back plate, which I'll take off. And there's this connector, and the connector is nice because we can do all the wiring, put everything together, and then connect it after. So I'll just set the smoke detector aside right now. What's important here is that we know that the white is neutral, the black is line or the hot wire, and red is the signal wire. So on the back of this contactor or relay, we have some information. So here we have a black wire, which again is the hot wire, the white, which is the neutral, pretty standard in North America. We have the red, which is the interconnect wire, so same as this. So those three we're just going to mirror together. And we also have the blue wire, which is the common contact. So that's going to be our input, and our output is going to be yellow for normally closed, orange is normally open, and then gray is really nice that they actually included this as a 9 volt DC signal. So if you have something like an Arduino or a Raspberry Pi, you can actually use this gray wire to send a signal to use in whatever way you like. So to send a text message or something similar. So this gray wire is actually a really nice feature of this relay. So for us, we're going to use the normally closed contact. So we want in a normal state for power to be flowing through our extension cord. If there's a signal, the normally closed contact will open, and we'll lose our power through our extension cord to our 3D printer, which will turn off, and hopefully the fire will go out. That's the idea. So first things that we want to do is bring our box over here. We've already stripped the wires. I'm going to pull this red wire off of here, take the red wire off of here. So we're going to grab some, we call them morettes here. Some people call them wire nuts or wire connectors. So the first thing that we want to do is we want to connect our signal wire. So next we have our power connections, and I'm going to do this in a couple steps so everybody can see what's going on. So we have our neutral connection. Our relay also needs our neutral. And in North America, we never switch the neutral, so we're not going to put the neutral through our contactor. I'm also going to put the neutral going to the printer under that moret, since it's not being switched. So we have 4 wires under there. Now if these were solid wires, I would twist them together with a pair of linesmen, but because they're braided, I'm just going to put them underneath the moret. Now the moret or the wire nut, you want to twist until you have a very good connection. And for added safety, I'm going to add electrical tape to all my morets, but I'm going to wait until the end to do that. This is our hot wire. We need to power our smoke detector. We need to power our relay. And we need to power our common screw, or our common normally closed contact. So those, all 4 of those, sorry, will go underneath the moret. So now we have power coming into our relay. It's working. We have power coming out on this normally closed contact, which is yellow, and this normally open contact is waiting for power. So what we want to do is connect the yellow wire, which is normally closed, to our outgoing wire going to our 3D printer. Now by connecting these two, and by plugging in this cord, I'd immediately have power on the female side, so my printer would power up. As soon as there's a signal going on this red wire, this normally closed contact would switch to open. I would lose power on this hot leg, so my 3D printer would lose power. What we have to worry about is this orange wire. So just because we don't put anything on this orange wire, it doesn't mean that there won't be power flow through here if there's an alarm. As soon as there's an alarm signal, we would have a power source going through there. So we definitely want to put a moret or a wire nut on here to prevent any shorting out in the box if there is an alarm. I like to cut the wire so that I know that I've got a good connection on there. I'm going to double check all your connections, make sure everything's tight. Now the last thing I want to do is, I won't be using this gray wire or the 9-volt wire right now. I am interested in using it eventually for my Raspberry Pi. I also have some Arduinos I'm learning how to use. So for now I'm just going to cut this wire, and it's 9-volt DC. We're not worried about high voltage, so we're just going to put a piece of electrical tape over top of it. And again, I cut the metal bit off. I don't like having the metal sticking out at all on the wire. So we'll just cover that up and we should be good to go. So I just wanted to show you this before I put everything in the junction box. I've got everything taped up here. This is really an unnecessary step if you've done a good job of putting your wire nuts on or your morets on. I'm just taking extra precaution. It's a good habit to get into, to put some electrical tape on your morets. Prevents them from untwisting. If you're moving this box around, vibrations can cause these to let go. And if you have a short against the box, again, you're tripping breakers or you're causing unnecessary damage to the insulation and to your wires. So always a good idea. So we'll stuff all these wires in here now. I like to twist the wires as I'm putting them in. It just prevents stress. You can get different style of these octagon boxes, or you can also get square boxes. The important thing is that they match the pattern of your smoke detector that you're mounting this to. I decided to get a deep octagon. It's a little deeper than most ceiling boxes that you would find holding up a light. Just because I knew I'd have quite a few wires in here, as well as this contactor. So we'll get all these wires stuffed in here. We'll get this cover put on. And we can tighten these screws. And again, this is a piece of plastic that we're putting on, so we don't want to tighten them too much. Just have them so they're snug. So now we've got all of our connections made. We can take the smoke detector. I've left this plastic housing on just to keep everything protected while we're installing it. I'm also not going to pull this battery tab out because we have a beep going on letting us know that there is no connection to power, and we don't need that at the moment, so keep that. This is the battery backup tab, so we'll keep that in there as well. Okay, so what I've brought here is the smoke detector with the cord attached, and we have our relays and everything built in. So I'm going to leave this battery backup still in there just because I don't want it beeping again when I'm carrying it around until I'm done my final installation, and then I'll remove that. So we'll start by plugging it in, and we should hear a beep. So that beep is just letting us know that we have power now. I don't know if you can see this or not, but there's a little green LED indicator there showing us that everything is go. It hasn't detected a alarm yet, and it's everything is in the clear. So we may get a warning at one point saying that the battery backup is not working. It might beep now and then, but I'm not too concerned about that right now. So the first things that we're going to do is check to make sure that we've got everything wired properly. And for that I've got this little tester right here, and what this will do is test for making sure that we have a bond that's connected back to earth, and that our neutral and our hot are correctly wired, and it'll check for a few other things there anyways. So plug it in, and what we're looking for is on this tester anyways, we're looking for two yellow lights, two orange lights. Okay, so as you can see, we've got two orange lights and no red, so everything is wired correctly from the panel all the way through to the end of our cord. So the next thing I want to do is check to make sure that our voltages are correct. So for that we're going to use a multimeter. Any voltmeter will work. Just make sure that the rating is correct for the voltage that you're using. You want to make sure this is AC, so it doesn't matter which side our probes go in. But we're going to check here. So here I have 120 volts, which is what we're after where I live. I'm also going to check it between the ground. So again, I should have 120 volts, which I do. And I also want to check to make sure that my neutral to ground is I have 0 volts on, which I should. And as you can see, we do there. So everything is working just like we like. So next I'm going to see if I can find a flash or a light bulb to plug into this, and we'll see if we can set off the smoke detector, and you'll be able to see if the light bulb goes out, then our circuit's working like it should. Okay, so we're ready to try this out here. I've got a couple matches and some paper. I'll turn this light on here. So we can see we have power through our extension cord, through our smoke detector, which is also powered up, and we have our light working, or 3D printer. So try and light this on fire here. So what we should see happen is once we have enough smoke, the smoke detector should go off. We'll hear some beeping. I'll try and silence that, and our light should go out pretty well immediately once the smoke detector starts going. So I just pushed the test button there to silence the alarm. Apparently pushing the silent silence button also turns our relay back on, which I'm not really happy about, but I suppose in the case of a fire, you would be pushing the test button anyways. So we can see our circuit works. As soon as we had enough smoke for the smoke detector to detect, it triggered the contactor that we wired in, and it killed power to our cord end, so either our light here or the 3D printer. So all in all, I'd say it's successful. That's what we're looking for. Thanks for watching.